This paper presents a head-mounted virtual reality study that compared gaze, head, and controller pointing for target selection of dynamically revealed targets. Existing studies in head-mounted 3D interaction have focused on pointing and selection tasks where all targets are visible to the user. We focus on selecting targets that must be revealed by users by moving their field of view. Our study compared the effects of screen width, target amplitude, and target width, and prior knowledge of target location on modality performance. We used a similar reciprocal 1D pointing task in the horizontal plane as previous work. For each selection sequence, participants perform 3 selections: a start selection to initiate a selection sequence, and 2 subsequent selections, one without prior knowledge of target position, and one with prior knowledge, which are used for data analysis. At the start of a selection sequence, the participant searches for the start target. The start target's placement to the left or right of a middle direction divider informs which direction the start target will be located. When found, participants selected start target to start the selection sequence. The participant then searches for the first target in the opposite direction until the target is found and selected. This is the condition where the participant has no prior knowledge of the target position. The participant then returns to the position of the start target to select the second target. This is the condition where the participant has prior knowledge of the target position. This also marks the end of the selection sequence. Each selection sequence varies in the amplitude between targets, target width, and display width. We examined the following modalities, which are frequently employed or becoming more common for interaction in modern HMD-based VR. The controller pointer is a decoupled pointer that is not related to the HMD. Pointing is performed by pointing via 6° of freedom handheld controller. In our implementation, the forward vector of the controller is displayed via a ray that intersects with the targets. The head pointer is coupled to the center of the HMD and follows the user's head movement. In our implementation, the head direction is visualized via a cursor. The gaze pointer is a semi-decoupled pointer where the user can freely point inside the current view, but is not able to point outside the view as with the controller. In our implementation, a cursor is displayed at the current gaze direction. We compare these modalities across multiple metrics and provide an analysis of individual trials. Please refer to the paper for full details.